How to avoid assembly problems from accumulating tolerances. Imagine building a machine where parts fit perfectly every time. If tolerances add up unexpectedly, it can cause jams, leaks, or misalignments. That's what we want to prevent. When parts are made with slight size variations, these small differences can stack up during assembly. If not managed well, the final product might be too tight or too loose, leading to assembly issues or even failure. To keep this from happening, start by understanding how these variations combine. Tolerance stack-up is the total effect of all individual part deviations. Some parts are more critical than others, so focus on the dimensions that directly impact how the assembly works. For example, if a shaft needs to fit into a bearing, controlling the diameter and bore size tightly is essential. Use analysis methods like worst-case analysis, which assumes all tolerances add in the worst way, or statistical analysis, which considers the likelihood of variations combining. The worst-case approach guarantees fit but can be costly because it requires tighter tolerances everywhere. Statistical methods like root-sum-square analysis help balance quality and cost by considering the probability of variations. Geometric dimensioning and tolerancing, or GD&T, is a standard way to specify how much a feature can vary in form, orientation, and location. It helps clarify what is acceptable and reduces ambiguity, making manufacturing and inspection easier. Always match tolerances to what your manufacturing process can reliably produce. Overly tight tolerances increase costs and defect rates without adding value. Planning the assembly sequence carefully and establishing proper reference points, called datums, helps control how errors propagate. Using flexible components like O-rings or compliant materials can absorb minor size differences, reducing the risk of assembly problems. During the design phase, include tolerance checks to spot potential issues early. Use feedback from prototypes and tests to refine your tolerances and improve the design. Lastly, avoid overspecifying tolerances that do not affect the function. Focus on what truly matters for performance and let other dimensions have more relaxed tolerances. By following these steps, understanding which dimensions are critical, choosing the right analysis methods, applying GD&T, matching manufacturing capabilities, planning assembly steps carefully, and validating your design, you can prevent problems caused by accumulated tolerances. This approach helps create reliable, cost-effective assemblies that perform as expected without surprises.